difficulty. Sorry for that. So let's say we're trying to add another column to students table. So I will say auto table students add gender. Okay, gender. So let's run that. Okay, the table column has been added. And next, let's say I want to add a constraint. Add auto table students also, and add, and then let's say constraints. Okay, the constraint I want to add is simply check gender. So chk gender. Okay, chk gender, and then we'll say check. Do you remember what I said? Just have parentheses, close it first. Okay, and then finally have one close this one. So when you have opening parentheses, just type the closing one. Just make sure that you won't miss. So sometimes we have so many. So make sure that you don't miss any. Okay. So what do we need to check? We need to check, make sure that gender is in the list. So list is done by a parentheses here. Okay. And then inside that, I can just say male, female. So all values will be inside single quote, all text values. Okay. Text values, data values are all inside single quotes. But if you have numbers, then don't put numbers inside the quotes. Okay, so that just add a constraint to it. Okay, something wrong. Can somebody check? Okay, let me say check gender in. So what is the error here?
There's no N in gender where you typed it.
There's no, oh, thank you. There's N. The gender, the column name is gender. Yeah, thank you. Okay, so now the table has been, the constraint has been added. So what if I want to drop the constraint? So drop table, not drop table, drop auto table. Draw auto table students. And then let's say I want to drop constraint. Okay, the name of constraint is say HK gender. So that's how it's just basically you do the same thing like columns. Okay. And then the constraint is removed. So this is actually a very useful command for database administrators. They often want to say remove constraints to maintain for example to copy data or to back up data. And then after the data has been copied over, then they just put a constraint back. Okay, because with constraint, some data cannot be inserted because it will violate constraints. The data copied will violate constraints. Okay. So we learned how to add a column, drop a column, add a constraint, drop a constraint. Now, last thing we want to do is I want to be able to change columns. Okay, so what we do is we'll say auto table. Let's just say, imagine that we have a column called a major here. Okay, student table has a major, and the major column is too small for some major titles. Some major titles, for example, can take up to 40 spaces. And then the 25 would not be enough, right? Okay. So I'm going to change this to what? To like 40 characters. So what I will do is I will say auto table students. Okay. And then we say modify, okay? And then you specify the column you want to modify, which is major, okay? And then let's say char 40. Okay, so you can modify multiple columns at the same time. Okay. And then extend and then run it. So that now if you run that describe students table again, describe students, then the table should have been changed. So now you should see that instead of 25, now you have 40. Okay. So what if at this point you say, I don't want that many space. I want to change it back. I want to change it back to 20, 25. Can I do that? The answer is no, you cannot. Why is that? Because the columns can only be expanded, cannot be shrunk. That's a restriction. Okay. The reason for that is you already have data inside the column. Okay. If you shrink it, very likely that you're going to cause this data loss. Okay. So Oracle will not allow you to shrink data size. Okay. But you can change it to different kind of data type too. So for example, say let's describe classes here. Okay, classes. Okay, say classes, we have one called title. The title at this point is a char and 100. That means for every title, Oracle is going to allocate 100 characters. So even though you have only like a few characters long, like 5 characters long, and Oracle will still give you 100 for the title. Okay, so in that case, let's say I want to change to vocal. Okay, so alto table classes. Okay, and then modify, and then we say title. Let's say I want vocal 2. Vocal 2 is Oracle type of vocal. Okay, vocal is standard. Almost every database has vocal 2, but Oracle has vocal 2, which is a little bit more efficient. Okay, so we still do 100. Okay, and modify. Okay, so table has been changed. Now, if you run this describe classes again, you should see that it's now changed to vocal 2 instead of char. All right, so now let's say this is a DDL for handling how to change existing tables. Okay, table structures. Add columns, add constraints, delete columns, delete constraints, and also change constraints, change columns. And now let me go back to slide and see what we're going to do next. Stop me if you have questions, okay? Current slide. So we did that. We did that. Okay, so next, let's say I want to create something called a sequence. A sequence is just like auto number generator. If you have access knowledge or even in some other database, they have auto number generator. Basically, the automatic generated numbers. So let me show you how to do that. So let's say I want to create a new sequence, new auto number generator that will generate new numbers starting from, for example, 11, and then increment every time by 2. Okay, so then what we do is create sequence. Create a sequence. Can you see? Can everyone see this? The font is pretty small. Let me see. I think I changed that last time. I'm not sure whether the change will be forever. So let me do that again. So font was not changed back. Was changed back. So let's change it to 16, maybe 18, 17, 18. 18 is probably big. Okay, so let's do that. Okay, create sequence, and then you give the name of sequence. Let's say SEQ some kind of ID, right? So when you start to enter values, so some column values, you want to use ID value, you want to use auto number generator, then you create a sequence. Okay, so that's the name of sequence, and then let's say start with 11. Okay, and then increment by say 1. Good. So the sequence will start. This sequence will start generating number of 11 or 11. We said 2, right? By 2. Let's see. Okay. So let's run that and create a sequence. Oh, something wrong. Increment. I misspelled. Okay. Increment. Okay. So sequence is created. Now let me see how the sequence will work. Okay. So let's say select seqid dot next val, next value from where? That's just from like a virtual table called dual, dual, okay? And then this one, the first one, we will give you 11, right? Now if you try it again, so give you 13. Try it again, give you 15. You see that? So every time we run this will give you a unique number. So that would be very useful if you generate some kind of unique numbers across many different users. For example, you have a lot of travel agents, right? They need to create new reservations, and the reservation ID might be like unique, right? Have to be unique. So every agent create a new reservation, and they will get a new unique ID. So that the sequence is a way to do. All right. And now let's say drop sequence is just doing this pretty much the same thing. So drop sequence, and then the name of sequence seqid, okay? And then that will delete the sequence. Sequence dropped. So now if you run this again, it will give you error message because your sequence does not exist. Is that clear? Okay, next, let's move on to next slide. Okay, so next one is so-called create drop view. So views is just like a query. So let's just say I want, remember last time we write the constraints, trying to view constraints, which constraint attached to which columns, right? So every time we have to remember those, right? So what we do is next, let's say I want to create I want to save the query result, okay? So remember what we did with let's say describe name of column. What is it called? User underscore cons columns, right? Did we do that? We're trying to say what columns, what constraints are attached to which columns. Okay. So let's say I want to have a constraint name, table name, and a column name. Okay. So we'll say select constraint name, and then table name, and the column name. So I want to say those three columns. And then from user underscore constraints cons underscore columns. Okay. So remember, this is the query. We're trying to find out which constraints are attached to which columns, right? Okay, so basically you get a list of constraints, and each one, which is from which table and attached to which column, right? So now let's say in the future, if you do that again, you're going to do that. You're going to write this statement again. Sometimes this statement is maybe complicated, but you want to save it. Okay, so this is how you save it. You're going to say create view. Okay, create a view, and then you give a name for the view. Let's say constraints or my constraints. Okay, just my constraints. Okay, as, and then whatever after that will be saved into that constraints. Okay, and then run it. So my constraint has been created, view has been created. All right, can you do it, everyone? Okay, so now let's say in the future, if I want to run this SQL statement again to say what are my constraints, I can just simply say select star from my constraints. So that way, I do not have to retype the whole command again. So I get those list of constraints. Okay, so basically, view is just like in Access. We did not do Access because we want to save time to do MongoDB, which is the future of Oracle for data analytics. So in Access, when every time you create a query, the query is actually just a view. Okay, so here is equivalent to that. Any questions? Anybody from online? Okay, so let me go to next slide. So if you want to delete a view, delete the saved query, just say drop view. Okay. Now, synonyms. Synonyms is just like just another name for another database object, for another table, for example. Let's just say we have I think we have an account called Scout, okay? And the Scout has a bunch of tables. One of the tables is called an EMP table. And then I, went to be able to access that, of course, Scout has to give you a privilege to access, okay? So that's the first thing. But then after that, you're going to do, so what you're going to do is that you're going to access that using regular query, like they say, select star from, let's say, how do you access Scout's employee table? You can say Scout.emp. So that is a way to access somebody else's table. So this is another person's table. There's the account name, there's a username. .emp. That the EMP table belongs to Scout. Okay. So let me see whether we can access that. I can have access to that. Yeah. All right. So for that Scout, the whole thing, this Scout EMP table. Let's just say I don't want to type that all the time. I just want to create like a synonym for that. Just like another name for that, so that in the future, I can just refer to that synonym instead of typing the whole thing. Okay, so what is how to create a synonym? Just say create synonym, the name of synonym for which table. Okay, so that is, we'll just do that. It says create synonym. And then I just say my synonym, name of synonym, just say that's employees. Okay. EMPs, and then say for Scout.emp. So in other words, I create a new name for this table. Okay. All right. So now synonym is created. So after you have that, in the future, if you want to access Scout.emp, you can just do this. You can just use that synonym instead. So let's say select star from employees. Okay, so that will give you all the data inside the employee table, employees, right? So there again, so basically we are using synonym to access Scout.emp table. Okay. Right, so you can also do that for your own table. So some of your tables may be so complicated that you want to create a synonym for that, then you can do that. Okay, so we can just create another synonym. Okay, create synonym. Let's just say cons. Okay, for what? For user underscore cons and columns. Let's just say that. Okay. Oh, something that. Invalid create comment. Synonym. I misspelled. Synonym. Okay. Create synonym cons and then okay. Okay, synonym is created. And now we can just say I don't want to type the whole thing like this. I can just describe, for example, describe cons. Okay. Describe cons. So then the synonym instead of the full name. What? Synonym. Oh, that's not table. So sorry for that. So we can actually use it. So let's say select constraint name. So describe is only for tables, not for synonyms. Select that from cons. Okay. For synonyms. So that will give you all the list of constraints. So you can access the user underscore cons underscore columns. All the columns, just say this one, I will just access one column data called constraint names. Okay, so that is a synonym. I think we are pretty much done. Okay, and the one last thing is so-called a database link. So just in case you have multiple databases, Maybe they are located in different locations, but then in your account, you want access to another database server's account, another user's account somewhere else. In that case, you can just create a database link inside your account, and then use that link in the future to access the data from a different database located somewhere else. Okay, so the way to create database link, basically you need to know how to access other database. So remember, you have to have a host name, you have to have IP, like a port number, and you also have the service name, right? And then you also have to have like a user account to be able to access that particular user's database objects. All right. So for example, here we have an example like this. We create database link, and that is called Scout. Okay. And then it will tell you where do you connect. You connect to Scout, identified by Tiger, so that the account, that password, remote database account and the password. And then using which link, okay, using which TNS names. So remember, TNS names embodies all 3 parameters already like this, okay? And if we do not have, if we have TNS link, TNS names, we can just use the TNS names, okay? And otherwise, we will have to provide a complete description like this. Using, and then single quote, and then put the entire description inside single quote, okay? So we cannot connect to this CBA 12C here because from the CBA 12C is behind the firewall, on campus firewall, okay? eCourse database is in the public, so eCourse database does not have access to University of Akron's database, even though we are here, but here the database link is actually linked from eCourse database to CBA database, okay? So because of that, we need like a firewall to establish a firewall. So we cannot do that. So what we're going to do is just use that to just connect to eCourse, okay? Connect to eCourse. So let's just use that as an example. Create database link. Okay, let's say, let's just create the names here. So let's say link is ScoutDB, okay? And then you say connect to Scout, identified by Tiger. That is the remote user's ID and the password. And then you say using, and then what do you use? Single quote, okay? We're gonna use ecourse.org. That I remember that was the TNS name we used, okay? Semicolon. Okay, so that is how you create a new database link. So this database link can be replaced by the description, which embodies all the 3 parameters we need, all right? So connect Scout, Tiger, that's account, that's a remote database account ID, account password, and then this is a link to the, this is like an alias or like a host string or TNS names for the remote database server, okay? So we should be able to run it. Unknown, which one is unknown? Let's see. Connect to Scout identified by Tiger using. There's nothing wrong here. So create a database link, ScoutDB. Let's see. There is an object user. Oh no, delete unknown command. Create database link. Why is unknown command? Create database link. Okay. Did I type anything wrong? Let me run it again. Database. Okay, it's great. Why have this one to begin with? Unknown command. Okay, so here database link is created. So after you have database link created, this is how you want to make connections. Make, for example, query to remote database. Remember, we Scout database have a table called EMP, right? So let's say I want to say select star from the name of table is EMP, and then you say add Scott DB. So using database link, say add remote database link. Okay. Now let's run that. Oh, that was wrong. SID was missing. So database link was having problem. Listener was not given the service name in description. So my database link, the alien's name was not right. Do you get the same error? So SID was missing in the connect data. So this database link has a problem. So maybe the user has a problem. Let me see. So I'm going to check on that. I'm going to check on this one. This may be saying that this database link was having problem, so may not be able to connect. This was in other words. So the alternative will be we have to provide a whole description like this. Okay. So let me see whether I can do that. Let me just copy this whole thing using from here. Everything inside a single quote. And I'm going to replace that by this one. Place equals.org. Okay. So make sure just single quote. And then here, host is equals.org. I remember that. Okay. And the service name was ol7.equals.org. Okay. ol7.equals. Port number is 1521. That's fine. Okay, so I think we have to drop the link first and then recreate it. Drop database link, which is Scott DB. Drop that first. So there is link dropped, and now let's recreate it. Okay, create it. And now let's run this statement again. Perfect. So now we have access to the remote database. Okay, so that's how we can do the remote database connection. All right. I think there's something extra here. It's extra. Okay. So anyway, so it was ignored. All right, so we finished the other database objects, how to create them, and that's all we need to know about Oracle database, okay? And then after the first exam, we are going to learn more about DML, data manipulation languages. Basically, we're dealing with data, okay? So I'm going to close that. Does anybody have questions? We're going to close this PowerPoint, and I don't think we need this developer for today's class, so I'm going to just minimize that for now. Okay. So what I need to do, let's go to a new PowerPoint, which is I just uploaded this morning. And we will go through two more concepts about data modeling. Okay, so let's see. Slideshow. Okay. And we did that yesterday, just this was like a homework review, so I'm going to skip the next one. And then we already did that. We say, how do we handle multi-valued attributes, right? So we use weak entities to do that, okay? And then the examples like, student has multiple majors, employee has multiple dependents, and then a catalog book and a book copies. In that case, book copies will be considered like a weak entity of a book. And course and the classes, course and the sections, that will be also considered sections of weak entity. So one course can have multiple sections, right? So that would be weak entities. So those are examples, okay? So we did that before, right? And then what if you have data on relationships? So in that case, you're going to use so-called associative entities. or gerunds. So for example, to be able to keep a student's grade, where do you keep student's grade? You cannot put in the student table, you cannot put in the class table, because the grade depends on both student and the class. So you should put into the middle one, create like a gerund in the middle, okay? So this is what, okay, this is another example here. Gerund between student and class here, so you need to create a gerund here and put a grade here, okay? And the previous example also is pretty popular example. So between auto and the product, and between auto and the products, yeah. And what if you want to keep track of data on like quantity of products you inside auto? So the quantity depends on the auto and also depends on the product. So it depends on both. So therefore you create associative entity in the middle and put a quantity as attribute in there, right? And this is just like a review of what we did already, okay? Okay, so now what if you have relationship between objects inside the same box? So we have, for example, in the employee, right? Employee box, employee have employee ID, employee name, employee job. And then how do you model the relationship between managers and employees? Managers and employees. Employees are managers. Managers are employees themselves. So essentially, in that case, you are creating the relationship between employee and employee. Okay. So if I'm going to draw that a whiteboard here, so let's see. Create a new whiteboard. So basically, you're going to have employee table, employee entity. Okay. And then employee have employee ID, which is identifying, right? Employee last name. Okay, maybe required, and then job, right? Which may be optional. So then you're trying to model the relationship, model managers. Who are the managers? Managers are themselves. So it's tempting to do something like this. You're trying to create another table called manager, another box called manager. And then when you do that, you realize that you're going to have employee ID here. Manager have employee ID, manager have employee name, right? And manager also have a job. So whatever attributes that employees have, managers also have, right? So then you create a relationship, right? Create a relationship between them. So then basically, essentially, this is just duplicate of what you already have. Okay, so instead of creating relationship between manager and employee, and then just imagine that you merge this with this one, and then create a relationship among employees themselves, like that. So this is so-called a recursive relationship. Okay, so how do we? So then you need to just imagine that this n is a manager, this n is employees. So one manager can manage many employees, right? Many employees, but one employee has one manager, right? So that relationship is one to many here. And then what about optionality? Optionality will be always optional to optional. We do not need to think for that case. So it's going to be optional. So just type, just make sure that the lines are dashed. Okay. All right. And then the question is, how am I going to convert that into relational model? This is the ER diagram, right? How am I going to convert that to relational model? Let's just do it as usual. So let's say I will have, so I'm going to create a table called employees. Okay. And then employee table is going to have employee ID, which is identifying attribute, employee last name, which is required, and employee job, okay, as they say optional here, okay? So you create that as normal, and then you handle one-to-many relationship between employee and employee, so you duplicate the primary key from one side to the many side. So one side primary key is employee ID, and the many side is also employees. So you're actually going to duplicate that same primary key inside the same place. Okay, so you're going to duplicate that EID here as a foreign key. Of course, you have to change name in this case, right? Because you cannot have two columns with exactly the same name. So you may call that as employee manager, MGM, for example. And then make that as a one foreign key. Is that foreign key required or optional? Depending on the receiving side. The receiving side, remember here, many side is dashed. So therefore, this is optional foreign key. Make sense?
Does that say? Oh, sorry. Go ahead.
You go ahead.
Okay. So basically you're going to you're going to create like a relational model in this way. So this is the ER diagram, and this is just like the employee table. So basically, employee table is going to have employee ID name, and then the manager's ID. ID.
Could you touch up on the reason behind why that employee table is like one to many in its own? Like why it's connected to itself again?
One manager can have one manager has many subordinates, many employees, many supervisors, but one supervisor has only one direct manager, right?
Okay.
Yeah, you can have many to many. So let's give you another example here. Suppose I have an example like this. I have course like a catalog course. Okay, course has course number, which is identifying, title, which may be required, and a credit. Okay, maybe this is also required. Okay, so now let's say, how do I model the relationship between course and their prerequisite? What are the prerequisites? Prerequisites are courses themselves, right? So instead of creating another box for prerequisite, we could just use relationship. So remember, it's always optional to optional. So just draw optional to optional to begin with, okay? Okay. And then, so in that case, we can just imagine this side is course and this side is a prerequisite. Just imagine, okay? Because we are actually combining both course and prerequisite into one box. Okay. And then the one, say this is the course and this is the course and this prerequisite. So one course may have multiple prerequisite, right? Multiple prerequisite, okay? And one prerequisite can be prerequisite for multiple courses, right? Does it make sense? Say, for example, 310 may be prerequisite of 350, 324, all that, right? So multiple prerequisites. So in this case, we have many-to-many relationships. Okay, so how do we handle that? Convert into relational model, so conversion. So you're going to create a courses table. And that will have course number as identifying attribute as the primary key, title is required, and the credit hours also required. Okay, so we have that box, the table representing the box. And now this is the many-to-many relationship. So what you need to do, you need to create a junction table again, right? So just say junction table is going to duplicate the primary key from both ends, both sides. So one end is course number, primary key, and that is going to be one foreign key, okay? And it's going to be required because it's junction table. What about other end? Other end is the same thing. It's also same course numbers. So you're going to create a course number again, duplicate twice, okay? But of course, you need to change the name, right? Because otherwise, you have two columns with identical names, which will not be allowed. So we can say change that to prereq course number. And that is another foreign key and also required. Okay? And then remember, this is like a junction table, so we can use both foreign keys as one composite primary key. Okay? So what is this? So we may call this table as prerequisites. Make sense? Okay. So next, let me go back to PowerPoint. Oh, this one. Okay. So let's continue. So basically, how do you handle relationship among entities of the same type? So this is the example. Okay, so we have more examples here. So for example, parse and assembly parse. So parse can be used to make other parse, right? And the course and the prerequisite, manager and supervisors. And then in airline industry, you have like a code-share flights, right? Flights, same flight can have different names. For example, United Airlines, for example, 354 may be also labeled as another airline's flight. So in that case, you have like a code-sharing flights. Okay, so all those will be a good example of a recursive relationship. This is the course, and this is the employee example, and the code-share example here. Okay. Now, what about you have entities that look similar but have some little bit differences? So, for example, we have two kinds. Suppose we have two kinds of employees. Okay, two kinds of employees. We have full-time employees or part-time employees. All employees, of course, are going to have employee ID, employee last name, first name, address, all that, right? Job title. But full-timers and part-timers are only different in very tiny aspects. For example, full-timer will have a salary, but part-timer does not have a salary. Part-timer has like a wage instead. All right. So in that case, we have two different kinds of entities that have many attributes in common. So part-timer, full-timers, and the corporate and individual customers. Okay, checking account, savings account. So they look very similar. Okay, but instead of duplicating both of them, duplicating all the common attributes, instead of doing that, we can do something like this. We can just do, say here, we can just say we have employee, create one common for all things that is common, say all put employee, all employees which are common attribute, I just put outside. So there's employee ID, employee last name, a job, or maybe there are some other attributes. Okay, so I'm going to just skip that. But then we have two special kinds of employees. One is full-timer. And second kind is part-timer. So full-timer have a salary, and the part-timer have a wage. So those are the only special attributes for part-timers, full-timers. So I put box inside the big box, small box inside the big box. So this is the small box is called subtype. And then the outer box is called a supertype. Entity, supertype. Just make sure that when you use this supertype, subtype, the subtype must be kind of a supertype. So for example, full-timer is kind of employee, part-timer is also kind of employee, okay? But if you do something like this, they say, what if somebody does this? They have customer have a customer number, customer name, and then they put something like this. They buy transaction. So there's a buy date, buy ID, purchase ID, buy ID, and buy date, all that, okay? And then when you draw something like this, you have to check, is it buy or kind of customer? That's not. So that's why this is incorrect, okay? Make sense? Okay. Now let's say, what if you have this kind of super subtypes? How do you convert that into relational model? How do you convert this, for example, employees table, which has both employee ID has like two subtypes inside the box. So this is what we do. First of all, you need to create one table for each box. Okay, so you're going to have full-timers. Okay. So full-timers at this point just have a salary, and that's optional. And then part-timers. Part-timers have just a wage, which is also optional. And then you create one for the whole employees. So you say a silver type also, employees. So that will have employee ID, employee last name, and the employee job is optional. This may be required, or there's also required. Is required. So just create one table for each. Okay, and then something important. Okay, then you need look at whether each table has its own primary key or not. If a table does not have primary key, basically, essentially, originally full-timer does not have a UID, part-timer does not have a UID. So in both cases, if it does not have a UID, so then you have to create artificial key for that. So maybe we create one for full-timer that's FT ID as a primary key, artificial primary key for that. Okay. If a table already has a UID, transform into primary key, then you don't do it. Okay. Just if it does not, then you create artificial key. And same thing for part-timers. Then we also create artificial key because it does not have a UID. So PT ID. And then that is primary artificial key for that too. Okay. And then what about employees? Employees already have EID, so employees we do not need to create artificial key. So just use that key already. Just use that one key. Okay. All right. So this is second step. Just create artificial key if necessary. The third step is you're going to duplicate the primary key from subtypes into supertypes. So in other words, you're going to create. Let me move this a little bit right here. So you're going to duplicate FT ID in here as one foreign key, and that foreign key will be always optional, always. And then do the same thing for part-timers ID. You also duplicate into the supertype. So PT ID. That is also optional. That is a foreign key. Okay. So if we're trying to draw the links, then this FT ID will be linked to here, and then this PT ID will be linked to here. Okay. So that is how we will handle the conversion of subtypes. Conversion of subtype. So now let's see. In this case, if you're trying to put data into this employee table, you have no problem with putting data into part-timers. Okay, wage, PTID. So each part-timer has ID, and then put a wage. Each full-time ID each full-time employees have ID and also employee. But then if you need for each employee you have a record in here. Okay, so that will include a company issued employee ID, last name, and job, and then. If that employee is full-time ID, then you duplicate that full-time ID into the full-time ID column. If that employee is part-time ID, part-time, then you create a part-time ID for that employee. So essentially, every time when you create a new row, new records here, okay, this column and this column are exclusive. Only one of them can have a value. Does it make sense? So if a person must be either full-timer or part-timer, cannot be both, right? So these two columns, only one of them can have values. So basically, both of them must be optional. And so because of this implementation, you have two foreign keys. Only one of them can have values. So this is actually called ARC implementation. So why is ARC? Because these two relationships, this relationship and this relationship, only one of them can exist. So you can just imagine this is ARC here. So this is exclusive relationship. These two primary key, foreign key relationships are exclusive. Okay. So basically, this is ARC implementation for supertype, subtype. There are three other types which are not as good as this one, so I'm going to ignore the three other types. So this ARC implementation is the most popular one. All right. Okay. So now let's do one more example. So this time, let's just say I want to do that inside the data model. Okay. data model. Okay, so let's say I'm going to create a new logical model, new subviews, right mouse click, new subview. Okay, so let's say I want to handle that. I have two types of customers. So customer. Okay. So I'll just create few columns, few attributes. So customer ID. Okay, let's just say this is child 15, the primary. Then customer name, customer last name. And this is child. Let's say that is 45 characters. Okay, and then that is mandatory. Okay, and let's do one more. Let's say email. And the child, let's say that is 50 characters. And maybe optional. Okay. Now let's say I have two kinds of customers. Corporate customer and individual customers. Okay, so first of all, I will draw them as usual. So let's say this is a corporate. Okay, corporate customer. And then let's say for corporate customer, you will have like a company name, right? Company. So company name, let's just say there's a child, let's say 25 characters. Okay, and then there's a child. There's one. And then let's say you also have like a contact, right? Contact. So that's a child. Let's make it 45 characters. And let's make that as a optional also. Okay. Contact. All right. Now I want to make this to be subtype of this customer. So this is what it will do. So go to the general one. Go to general one, and then you select supertype. Supertype is a customer. Did everybody hear me? Does everybody see what I did? So go to general tab, and find out what is the supertype for that attribute, for that entity we just created, and apply. And now all of a sudden, this one will go inside the box. Okay. Let's do that again. So this time, let's say I want to have individual customers. Individual customers. So individual customers, of course, is going to have a last name, first name, L name. And that is child, 45 characters. Okay, let's say required. Apply. And also last name, first name, last name. Did I put last name, first name? Okay, first name. Okay. And then there's also a child. So let's say there's also 45 characters. Okay, mandatory. And after that, let's just say I want to make this to be subtype of customers also. So then we'll select general type and then select supertype. Customer supertype. Apply. So now you have two sub boxes inside. Okay. Now let's click somewhere else. And then we can make this box slightly bigger, make this smaller, so that we can just put both of them side by side. So this is how we draw that. Okay, draw that. Now, how do we draw? Do I have time? What? I have 10 minutes. Okay, perfect. So now let's say I have. Customer, let's say we have orders, okay? Let's create order here. Okay, so order, let's just create a couple of attributes. Let's say OID. OID, let's just use child. And then let's say that will be, say, order ID 15 characters. And that is the primary key. Okay. Apply. Let's put one more. Let's say order date. order date, which is data time. So let's say that is mandatory. Okay, so let's stop here. Okay, and then let's say, suppose I need to keep track of orders and their back orders. Orders and the back orders. So sometimes when the order is not fully shipped, you create a back order out of it, right? Make sense? So essentially now we are trying to figure out the relationship between order and then those back orders that spawn off from the original order. So the relationship between orders and orders. Back orders are orders, orders are orders, right? So we have like a recursive relationship also. So to do that, we will just do whatever relationship, does not matter. Okay, just one to many. Okay, so click inside, and then click again inside. So then we give a name. So back ordered by. Okay, let's have a name, back ordered by. Okay, so one order has, so just imagine, so both sides are order, so now you have to be careful. Okay, so order, let's say which one is back order. Okay, let's just the right hand side is the back order, the left hand side is or just order, regular order. Okay, one order may have multiple back orders, right? One order may have multiple back orders. Okay, and one back order is coming off one order, so that should be one here. Yeah. Okay. So remember, this is right-hand side one. The target one is back order. This is just another order. Just imagine, okay? Essentially, they are the same thing. And then optionality, they are always optional to optional. So do not need to think, okay? Always optional to optional. And press apply. Okay. So now you have this recursive relationship. Okay. And then, of course, customer make orders. So we can have one-to-many relationships between customer and orders here. Okay, so that will be mix. Okay, takes order. One customer can take many orders. One order is made by one customer. Okay, customer may or may not have order, but order will definitely have a customer. So this side is required. Okay. So we have that relationship. Okay. All right, now, how many minutes we have? So how do we handle, so basically the way to handle recursive after you have relational model is just implement them as usual. But then let's say, how can we handle the other one, the relationship? Say we have like an ARC implementation, ARC. So how do we implement ARC? Okay, so I'm going to write SQL statements to implement supertype subtypes. Okay, so I'm going to exit that out. So remember, we have this ARC here, right? So let's just try to create a table part-timers, full-timers, and employees. Let's say, how can we implement the ARC, okay? So I'm going to remove, create this PowerPoint timers, okay? Parentheses, and have salary, which is number, right? So let's just put a number, maybe 7, 2. Okay, and then that is optional. And then it's FT ID. And that is just to make up something. So how many employees you may have? How many employees you may have? Just imagine that you have like maybe like tens of thousands employees. So let's just child 5 or number 5. And number 5. Okay. All right, so those are the 2 columns, and now we create a constraint and PK, FT, and then we say primary key. Primary key is FT ID. We are done. That one. Now let's do the same thing for part-timers. Create table and the part-timers. Okay, parentheses, And then we have wage. So for wage, you'll use number maybe 4, 2. So then you can have up to $99.99 per hour, something like that. That is also optional. And then we have a PTID. PTID. And then let's just say part-timers, we have a fewer, so maybe 3 digits should be enough. Let's say number 3, okay, for part-time ID. And then there has constraint primary key also, so that is PT, and then primary key, which is PT ID. Okay, parentheses. Okay, so those 2 tables are created as normal. Now let's create table employees. Employees. Okay, so employee table have employee ID, EID. So let's just say I will use a number, or let's use 7-digit number for that. Okay, so that's going to be a part of primary key. So it's going to be not a null anyway. And then employee last name. Employee last name. Okay, so that's char, maybe 45 characters, and that is not null. Okay, job, char, 25, and then let's just say that's not null too. And finally, we have 2 IDs, FT ID. Remember the referential integrity rules, so we have to use this 5, number 5 as data type. Referential integrity rule number 1, and that is not mandatory. Do the same thing, PT ID, and that will be number 3, matching this one. Matching this one, okay? All right. And that's all the columns. Now let's do constraint. Constraint, PK first. So PK for EMP, and then you say primary key, which is EID. And then we have two foreign key constraints. Constraint FK, EMP, and I say FT, full-timer. And then foreign key is FT ID. And then we say references to full-timers. Do the same thing for the other one, constraint FK, EMP, then part-timers, foreign key, then PT ID. References, okay, part-timers. Okay, so now let's try to do arc. So make sure that the FT ID and the part-time ID, only one of them can have values. So we do that with check constraint. So check, let's say check arc, okay? And then say check. And then before you do the actual content, just close it. Parentheses, close it first, okay? And now let's go inside. The inside, let's just do 2 rows, 2 columns, 2 rows, 2 places. So it's a little bit more involved. So we have to say FTID is null, and so that one is missing. Then PTID is not null. So this one, or let's go to the next one, or FTID is not null, and PT ID is null. So by just typing in different lines to make things clear, okay? So this means you check that if FTID is null, then this must be not null. And otherwise it's the opposite. So you put either case or this, okay? So then that is finished, and then go to parentheses, close it. So then this is how to implement this relational model, the arc implementation. So only thing extra is this is arc check arcs. All right, I think we just right on time. Let me ask whether anybody have last minute questions.
Can you just leave that up for a second?
Okay, sure.
For our exam, are the questions going to be multiple choice, like the
You're
homework
going to have
questions?
multiple choices. You're going to also have hands-on questions.
Okay.
So you may have like a 70, 60, 70% multiple choices, and then hands-on questions. So basically, hands-on questions, you say that we learn how to do ER modeling, how to do relational model, converting ER to relational model, and how we write like SQL code. So apparently, you should study. So basically, your homework this time include all three. So you make sure that you do your homework independently this time, and that would be a good check to see whether you're ready for the exam. Okay.
Can you just scroll down to the bottom?
Go down to the bottom. How many questions on the exam? For multiple choice questions, I think we'll have like so each 1 point for each question. So basically, you may have like 60 or 70 questions in there. Yeah. So make sure you manage like every minute finish one question. Of course, some questions will be easy. Some of your homework questions will go back to the exam. Okay. So for those questions, you should just take no time to finish. And then some questions you may need to think a little bit longer time, but on average, for multiple choice questions, you should be able to finish in 30, 35 minutes. Okay? Yeah. Anybody else has a question? I'm going to start share the recording first. What happened?